building a model, starting with your training dataset, validation dataset, and testing dataset. Training dataset where you train model after pre-processing of your data, right? You work on to create a model. Validation dataset where you carry out certain feature engineering, right? Optimization, hyper tuning. We have not discussed that. Maybe next session or session after that we'll discuss that. Testing dataset is where actually you test whether the model which you created will it work on the actual field, right? Because what happens if I'm creating a model taking all the data points, my model which has been created might be biased, right? So to reduce the bias, to check that okay, the model which I've created can give a similar result, if not better, right? Close to the result which I have created in the training data set. If it is coming almost similar in the testing data set, that means my model can reproduce the results in the actual when it works. Think about a like kind of any sales promotion, right? From the last few years of data we have collected, we create a model that okay, these kind of sales promotions, if you include, then our revenue will increase, right? uh, and there are different variables, the store size, the kind of coupons or the kind of discounts, timing of discount, right? All those variables are there. But what I have done that I have created a model using the past data, right? Unless I do certain kind of randomization to check that, right, that whether this model which I've created can actually work in a different data set, right? And I just without testing that I send it to actual implementation production, right? That might create lot of errors, right? And that is the part where we are creating ideally training and testing data set. Some cases you might have to create a validation data set. Validation data set is not always created. Mostly if you see 70-30 ratio or 80-20 ratio, if I have 1000 lines of data, 1000 rows of data, randomly 800 data will be taken as a training data set and 200 data points will be taken as a testing data set, right? I'll show that how automatically in SAS Studio it will be created. Okay. So predictive analytics using linear regression. Uh, but the idea always remember it is not, though the course is about predictive analytics using SAS, right? But at the end we are using it to for certain business results or insights, right? Our aim is to create certain decision or help the management to take certain decisions, right? Same example what we discussed in the last class. I'll take, let's say for a Google, like kind of a YouTube. Prediction is that what video the learner wants to watch next, right? Then what will be the decision of that, right? How that management, the YouTube management or the YouTube product manager is going to use that data, use that information, use that insight. Because now I know that okay, if I create a classification, if I know that okay, these certain individuals, if I do certain kind of cluster analysis or certain kind of logistics regression or decision tree, and I find out that okay, after watching these videos, this person will watch maybe a next video in the series or might move into a some other video, right? Yes or no, like that I have created the model, and it is good amount of accuracy is there, right? At least 70 to 80% of accuracy is there. So what video the learner want to watch next, that I am able to predict to certain 80% of accuracy, right? But then next what? So that is not something, so that is obviously that insight or that conclusion need to be used in certain way, right? So how that product manager is going to use that? So this video in the recommendation bar, the next videos which are potentially the customer is going to see, that will be seen in the recommendation bar, so that he or she need not have to search what is the next video. Whatever happens whenever we watch certain kind of songs, next songs will be in the similar taste. Similarly, or if you are watching certain learning videos, let's say on statistics or machine learning, similar videos will be shown in our recommended recommendation bar, right? Similarly, let's say for a Amazon or a Flipkart, probability someone will click on a search result, right? Whether if I put a link there for a new product or for a new offer, let's say sale is happening, or let's say certain banks, ICICI or HDFC, giving certain 15% discount or 20% discount in their card. If I put that offer, whether somebody is going to click on that, right? So if now what happens, now I can predict whether somebody who are going to click on that, what is the chance of somebody who is visiting the web page, what is the chance of clicking that page, right? So that is the prediction I can make. I can create a model which can predict to certain extent, certain accuracy, that whether somebody is going to click that link, click the, or search that whatever product. Next, how I'm going to use that in actual business? If percentage of probability of click is 0.12, because I need not have to show this kind of advertisement, show those kind of offers to all individuals. Amazon web page will have different versions. So some of you who are in this market research, we are talking something about A/B testing or multivariate testing. Not necessarily the page what you are seeing, home page, the items which are listed there will not be similar for me. All of us are looking into different offers, different slight changes in offers, depending upon our past website visits, right? And how they make that decision. Let's say they can put algorithm where it will say if the probability p click, that means probability of clicking that page is greater than 0.12, then preface the web page, right? For those kind of individuals who are inclined to click that page, probability of clicking is greater than 0.12 or zero point 0.2 or zero point 0.4, then preface that web page so that when they click, it will be automatically, the loading time will be in millisecond, right? Otherwise, what will happen if it is a creating or fetching a new page, it might take 6 seconds or 10 seconds, right? The customer might not wait for them. So when I'm targeting those customers, the web page need to load in millisecond, right? So I would have prefaced that. Prefaced means you make it load once the customer is signing in, knowing that okay, this customer has a higher probability of clicking the next page. You have already preloaded that page. So once that person clicks, the page is ready, right? What fraction of a video ad the user will watch, right? So that is again a revenue stream for YouTube, right? The advertisement what we see right now, obviously they have made it mandatory. We cannot skip also, right? But some videos they strategically put, right? If let's say we are watching something on personal finances, they'll try to put related videos, related advertisement, not only the videos we have discussed, related advertisement to that. If you're learning something on Python or something, they'll try to show certain course offerings from Udemy or Coursera, because there is a greater chance that I might not skip that video after 5 seconds. I might continue watching that video, right? So what fraction of a video ad, that advertisement, the user will watch? If it is more than let's say 50 percentage or 30 percentage, or if it is less than 30 percentage, if a small fraction, don't show the user that advertisement. If let's say there is a chance that very high chance that the person will not, or person will skip the video, then don't show the video, because anyhow after 5 seconds he is just waiting to skip the video, right? This is how they keep on optimizing their model, optimizing the predictive models, right? uh, so if you simply throw everything at a model and see, so this is where your little bit of experience in that area will come into picture, right? Otherwise what will happen if you do not have knowledge into that? Let's say on what basis a Netflix create the algorithm, on what basis users watch different videos, how do they select the different videos, right? You need to have that kind of, even not the experience, at least the knowledge about that sector or industry. Same thing with healthcare, same thing with banking, insurance, same thing with sales and marketing. Any sector you take, you need to have basic knowledge about what kind of parameters, what kind of variables you need to use. Output predict whether the user will share the article. Again, similar to that, ideal outcome of the decision will be so the user articles they will like. For the newspaper business, right now everything is going online. Lot of kind of sites where people used to buy, right now they are struggling, right? Newspaper article business, magazine businesses are struggling. People do not have the time to read such a length. In case they are visiting your website, you should be ready with the next articles. So this is where making a strong connection between your prediction and business outcome or business decision has to be there, right? because the model you are creating not only for the model sake or whatever your r square, adjusted r square, or whatever matrices you are using, it is of no value if it doesn't create a decision, or it is doesn't help in taking a decision, right? So how you use your model, the prediction model, what you are using different techniques, how you are going to use that model in real time in response to a user activity that is online, right? So in some of you were in the Tableau class, right? So you can create a data visualization, right, which can be refreshed if you link it into a database. It continuously fetch within few milliseconds or few seconds, depending upon how much lag time you have provided, and it will continuously update the dashboard. Or you can make it offline. Every 3 days or every day in the night, it will fetch data, update the dashboard, and it is ready for the next day. But it is offline. That means real-time data is not getting refreshed. There will be 1 day gap. Same thing with the prediction models also, right? So if let's say credit card company or a this e-commerce companies, they will be using real-time data. They cannot, or they do not have the uh, kind of they generally will not use a offline model because that will not be of any benefit. Let's say this sales for Holi festival or any festival is coming, so they will be using the prediction model in real time. That means they have created a model, tested it, and now it is getting launched. So real time data will come, and the modelers, predictive modelers, data scientists will be working in the backend to update the model. In case the model is not working, they'll keep updating the model. Some cases, let's say, which is there can be a time gap, right? Let's say sales prediction. I want to predict for a normal FMCG company what will be the sales for next week or next month, right? It is not that it is not a real time. You need not. You can create a real time prediction, but it is need not be that accurate, right? You can take a time gap of 7 days. Every 7 days, you will refresh the model. You will get new data, refresh the model, and send the new forecasting, right? So this is the same example what we are seeing in the last slide. If the prediction, if the probability of somebody clicking a page, clicking a link is more than 5% or 10%, right? Then send a notification. So some of you, if you are using these personal finance apps, if I just click on certain pages, suddenly after a few seconds I'll get a WhatsApp message saying that okay, you have, or SMS saying that you have used this feature, are you interested in that, then we will be giving you certain offers, right? So that based on my user like browsing behavior, they have, they must have created a model. Most of the like kind of this kind of applications, they will have a inbuilt model which are working in a real time mode. Anytime I click, or anytime you click on certain links, certain pages, you'll get an automated message, WhatsApp, saying that are you interested in this kind of finance or whatever the different application you are using, right? Any questions on this? I hope the difference between, or the why you are using these kind of predictions for different decisions is clear. Any question, any doubt? Okay, so now like from this today's class, if you want to take 2 point, first point we have already discussed in previous classes, so that will be repetition of that. But now what happens when I'm creating this kind of prediction, uh, whatever algorithm, whatever technique I'm using, what kind of data set, or like how it is valid, right? So let me try to show you through an example. I'll take the same what I showed in the last class. Just let me take that Excel file. Okay. This is again a hypothetical data talking about, let's say, Y is your monthly internship stipend, what you are getting. X is the age, right? Again, this is a hypothetical data, not actual data. Now what happens if I want to predict something, let's say what will be somebody's stipend if that person is let's say 19-year-old or 27-year-old, right? How will I do that? You got my question? X is the age, right? X is the age of that person or that student. Y is the rupee amount, stipend amount per month the person has earned, right? So I have a hypothetical data set of 10 or 12 point. So I'll create a model y is equal to this. I created by just taking yx. I have created a different model with y is equal to this much plus x square, right? So now the question is, if I want to predict, because we are discussing about prediction, right? So this is the data. Now let's say somebody who is 19-year-old. For that person, I want to predict what will be the stipend. How will I do that? Or for a person who is 27-year-old, if I want to predict what will be the kind of stipend, monthly stipend, how will I do that?
Sir, we'll substitute in the regression equation.
Okay. So in this equation or whichever equation you are using, let's say this one with 7.0412, this is actually x square because x here is x square plus 3000 because this has a better r square. Or I can go with the simpler model, which though have a very less coefficient of determination or r square. Let's say I take this model, right? Y is equal to 162.15 multiplied by x plus 3000, right? Then is this correct, or is there any issue doing that? Or same thing with the 27 also, right? Rather than x, I can put 27 and I can predict. Let me do that. So if I say 162.15 multiplied by x is 19 plus 3000, 6080. Okay, so I get this kind of values for a 19-year-old. Approximately, he is going to earn around 6,000 rupees. This for this person 7,378, right? Something like, though it is not a very good model, it shows that as the age increases, the stipend amount might increase, right? So, what do you think? Is there anything wrong with this, or kind of what are the problems you can foresee?
Sir, we are not considering other factors which might affect the stipend.
Among just a moment, I have just one moment. Okay, sorry for that. Yeah, Amok, you were telling that we have not, because this model obviously is not a very good model with only 11% explainability, right? R square 11 0.1184 means this age is only able to explain 11 percentage variation, 11.84 percentage variation in change in your whatever salary or the stipend, right? Okay, that is a valid point. This is not actually perfect or a good model to make this kind of prediction, right? So ideally, we should take additional variables. What other thing you foresee, or what is a problem you think? Anyone else?
If we just consider the two data that we are given, income and the stipend amount and the age, we can clearly see that the stipend amount increases as the age increases. But in case of 19 years, it is overvalued and in case of 27, the amount is undervalued.
Okay, but that is what is coming out of your model, right? Yes, because that is a error, right? If you see for this person 25, somebody is getting 9,200 also, right? So that is a issue with
Yes,
the
sir.
explainability what we discussed, right? Because your model is not a very good model. It can able to explain only 11% of these changes, right? That's why these numbers might not be entirely correct. That prediction numbers might not be entirely correct. So that's what Mog was also telling. Ideally, you should take additional variables which will be able to predict or able to help us creating a better model. But apart from that, what do you think is a major fault in this kind of assumptions? I'll give you a hint. When I'm taking these numbers, there is a problem. When I take this number 19 or when I take this number 27, there is a big issue. Anybody want to make a try? That part is very clear. Like what Anessa and Amog was talking about. This model is not a good model. Hypothetical data, I just taken two variables, 11% variation, and that's why kind of the results are coming very like arbitrary, right? Ideally, in the production, we'll not be able to use this kind of. They will have a minimum matrices, right? Okay. So the point is there is two different things. What we are just doing here is extrapolation. So there is two things, prediction and extrapolation. Prediction only will work whenever we are creating a prediction model with the range of data set what we have taken. So here I'll take the minimum is 21, maximum is 25. When we are making a prediction, this model is only valid, though the model is very poor. The equation is a very poor substitute for a actual prediction. But that equation is only valid in this range. If I have taken multiple independent variable, it will be valid only in the range of those independent variables. When I am trying to predict something outside of this range, because if you see 21 is the lowest age value, 25 is the highest age value, this model might not work. Okay, and that is the biggest mistake most of the times when you are using prediction people do. People actually do extrapolation but try to see that or say that this is a prediction. Prediction models are only valid within the range of the your input variables, whatever variables you have taken. So I can predict for a 21 and a half or any which is not there in between here, 24.5, any age between 21 to 25. If I'm trying to create or predict, ideally this equation I should not use, or if I'm using, I should go ahead with certain prediction intervals or extrapolation variables, not with the same model what I'm using, right? So that is what I am I was trying to tell. Our prediction, whenever we are talking about prediction, that only will work within the range of data which you have used for your model, right? So let's say Amazon or let's say that YouTube, they are targeting certain individuals, right? So they have taken data from Asia, a few countries in Asia, in certain age group, certain geographies, and all those things. The model prediction only will work for this Asia region, right? Because the input variables are specific to Asia region, and the range will it will work in that region. If they have taken the age group from, let's say, those people who watch YouTube videos, and they have taken a age group from 18 to 40, so all their predictions will work as long as those who are logging in are between that age group. If somebody logs in, obviously people above 45, 50 also will be watching YouTube. For them, the model might not work perfectly. If I'm trying to predict what will be their behavior, somebody who is 50-year-old or 55-year-old, when my data set only consists of people who are from 18 to 45, my model might not work properly. Same thing here. Let's say obviously this is a very small data, but if I've taken a data from a age group from 21 to 25, my prediction model is valid, though it is very poor, but it is still valid within that age range. If I'm trying to predict something below the range or something above the range, that model might not work, right? Is this part clear or any doubt? Any
So then
question on
how are we going to predict for the input variables that are not, that we have not
you?
taken?
Ideally, you should not do it, at least in the business, and that is where these newspapers do all this kind of prediction. And I'll show you a newspaper clip. So that is something known as the extrapolation. Extrapolation has to come with a lot of interval. So there you cannot make a point estimation. So here what I'm saying, 19-year-old will I make 6,080 rupees or 6,100 rupees. When I'm making extrapolation, extrapolation cannot be exact. I have to say that okay, 19-year-old will make within the range of, let's say, with the confidence interval of 5,600 to 6,500. Exact point estimation I will not be able to make because my prediction model will not work. So ideally, to answer your question, for the business objectives, whenever you are using your prediction model, take the sample from the population. When you are collecting sample, take the sample for which you are going to predict. You cannot predict for a individual or predict for a parameter if you have not taken that data in the sample. So let's say that Amazon offers what we are talking about. If you have taken certain customer data set, that offer or that prediction of somebody clicking a page or somebody buying certain product will work only for those people. If I'm using that model for the other individuals, it might not work. It will have a lot of range gap, right? So in this particular case, if I want to predict somebody who is within a 19-year-old or a 27-year-old, I have to put a confidence interval. I cannot say that a 27-year-old will kind of earn 7,300 or 7,400 rupees. It has to have a certain confidence interval. So that is where uh, somebody would have created forecasting, right? So forecasting basically for the extrapolation, because we are forecasting. So forecasting generally for the future, right? That data is not available. We are kind of assuming some data and saying that okay, what will sales will happen if this is the trend. So trend line always come with that, not a single line, right? So there will be always a confidence interval. Okay, the sales might fall under this range. So in Tableau, if some of you have, I had shown that forecasting, right? So when you are creating a trend line, it will be always, in this case also you can. Here range is not showing. Ideally, all the trend lines should have a range. Whenever we are predicting for the future, right? It should have a range. And that is where your extrapolation comes into picture. That will no longer be a prediction. Prediction where I can predict that, okay, whether this customer will watch a video or this customer will kind of, let's say, buy certain items or not. Those things won't work if I have not taken a similar data set, right?
So this will this also work in cases of if we take stock markets and all, in the prediction of whether the stock market, how will it perform for the next 30 days or maybe next 60 days?
Yes, so that is where actually you are doing extrapolation, right? Because you are forecasting something, right?
Yes,
That
sir.
data is not there. So that is where the ideal is, if somebody says ITC will go within next 30 days, it will be 270. You should not take that data. It has to have in a range. It might fall below. So I'm not telling you cannot create extrapolation, but extrapolation with a point estimation. When somebody says sale will happen 3,000 rupees or 2,000 rupees, that is a wrong approach. You have to give a range. It might fall below certain or it might go up, right? That range has to be there. Same thing with the stock prices also. It might be within a range.
Okay, sir.
So obviously there will be always uncertainty. There won't be any model which will be like perfect and say that okay, I'll be able to predict with this. So that is where your explainability comes into picture, right? So this model, we know that there will be certain issues, that will be certain residuals or errors associated. Extrapolation, if I'm applying a model estimate to values to outside of the realm of the original data, like I had taken the like age group from 21 to 25, but I want to predict from 19, or I want to predict something for 25, right? So that is where the extrapolation comes into picture. So this is where newspaper articles, right? Momentous printed 2156 Olympics on the year 2156 if Olympic happens, right? The what does this kind of trend line says? Over the last few years or the century, right, where Olympics has happened, right? Women sprinters, the way they are improving the speed, right? It is better than the male sprinters, though it is in millisecond, right? So the idea is by this year, the women sprinters will, like if a race happens, they will outrun the male sprinters. I think this is for 100 meters or something. Yes, 100-meter sprint. So that is where your trend line will come into picture. That might decay also. So if you see there are multiple range, it might go beyond below or go up also, right? That means that sprinters, it is not necessarily they'll say that okay, by 2156 women sprinters will run the 100-meter within 7.2 seconds, and male sprinters will take 8 or 7.5 seconds. It is within a range. So whenever you are doing extrapolation, the prediction which is not within the interval of the data you have taken, it has to come with certain confidence interval or within certain range of errors, right? And that is where what they've shown.
So I have a question.
Yeah.
So that you talked about the prediction model and the extrapolation. So does this work in case of logistic regression as well, where we are trying to find the chance of whether this event will occur or not?
Yes. So there also, like when you talk about what will happen when you go beyond a certain data point which is not there, right? So there what will predict whether that so in logistics regression, what is your out 0 or 1, whether somebody will buy or not, right? Or somebody will take offer or not, or watch a video or not. So whatever your calculation is happening, that will come with error. So what will say that okay, I am predicting whether somebody will buy it or somebody will click on an offer or not, with but with this much error, right? So your chance, or right now if I'm putting a logistics regression, what will say, yes, with 80% accuracy I'm telling that okay, this person will click on the page, or this person we won't watch that video. But when I'm doing that for extrapolation, what I have to say, my error rate will increase. That 80% will not be 80% anymore. That will reduce by, let's say, whatever 5% or 10%. So that is the error interval you have to use. So prediction, that model which you have created will work only for with that 80% accuracy within that data range. Once you are going beyond that range, your error percentage will increase. So that means that 80% accuracy will come down by 10%, 20%, depending upon whatever your model says. You can say that, okay, that person might click on that video, but my accuracy rate has decreased to, let's say, 60% or 70%. You will not be that certain.
Okay, sir.
So basically the point is, whatever algorithm, whatever technique you are using, whatever model you are creating, it is valid within that range. If you're going beyond that range, your model accuracy will decrease. So you have to give a range of errors, right? Obviously in linear regression, you can give a range of errors. In logistic regression, because output is binary, your error percentage will decrease. Sorry, error percentage will increase, accuracy percentage will decrease.
Okay, sir.
Same thing with decision tree also. Whatever the binary output models are there. So use of regression for prediction. So there are two usage of kind of regression. One is for prediction, where I'm only interested in the y part, right? I want to predict y as kind of best possible as I can, right? I obviously I'm interested in what variables I'm taking, but due to different transformations. So what we'll learn in the next class, different transformations, different types of regression. Regression is actually the simplest and the best model where interpretability is there. Once you get into a little bit of complex models, interpretability, that means interpretability means what? Like, I know that which are the dependent variables, which are which are the independent variables, which are impacting my dependent variable. So that interpretation will be very difficult when I get into a, let's say, neural network or a complex model, right? I use a decision tree, then I use random forest, then it becomes very difficult, right? So as and when we get into a complex model, our interpretability decreases, but our model prediction might improve, right? Because our aim is to improve the model prediction. Sometimes we have to compromise with our interpretability. But other area like what we have discussed in business research, right? When we are doing certain hypothesis testing, or when I want to know that, let's say, vaccine development or the, let's say, COVID death, right? So the one use of regression model is to predict COVID death, right? So that will fall into kind of prediction model. But other usage of that same model can be to understand the variables, to understand the importance of those variables who cause the final death, maybe the obesity, maybe diabetes, maybe like whatever lungs problem, other like health issues. That actually, apart from that, once somebody getting affected with COVID, that is increasing the death percentage, right? Somebody, if somebody is getting affected by COVID, whether that person will die or not is related to other variables, right? If my aim is to understand what are those variables, which is the most important variable, right? I'll be mostly focused on these coefficients, right? Whichever has the highest value, that coefficient, standardized regression coefficient, that means that is a very important factor, that is an important variable, right? So same model, the equation remains same, but what is our aim? For our prediction, I will not care about what is beta 0, beta 1, beta k, that model will take care. What I'll be interested in, whether I'm able to predict y with a lot of accuracy. My R-square value is great and I am able to predict that well enough. But if I want to explain something, same thing, if I want to predict what is the COVID death, then my prediction model will work. Same model I can use to explain the variable, saying that, okay, let's say your obesity or more BMI index or the same insurance model what you used, right? If I want to predict only the profit, right? So I create model different combinations and I'll see that which model, which variables are able to predict my or profit with lot of accuracy, right? But my intention will be to understand what are the importance of those variables, whether number of children, smokers, whatever other factors we had taken from the state they belong to, age, gender, right? And accordingly to plan certain whatever your promotions or premium amount, right? In that case, I am using that model to explore or analyze certain variables, right? So remember the two important, and whenever you are building a model, remember what is your objective, only for the prediction or also for the explanation, right? Like I said, in some cases, mostly on banking and finance, right? Complex models generally avoided, though they know that it will have better predictability. Like I said, there is a regulation in US and Europe, because if I create a model and I take certain variables which is very sensitive in nature, right? And I was giving you that example, right? If I create a model which will predict the credit score, and I have taken a variable, let's say caste, or I have taken a variable on, let's say, your religion. In India, we do not have that much strong legal case, but in USA, it will be like Fed or the the authorities can take action against that bank. So that is where your interpretability, because somebody can put a class action suit saying that, okay, they are kind of discriminating against us, discriminating against a race, or discriminating against a gender, right? So they make sure that the model which they are creating have a And they cannot go and say that, okay, because I have used a neural network, what kind of variables the model is taking, I do not know. They cannot say that, though they know that neural network, if they use for the model, it might give a better result, better accuracy, right? So that time the model need to have a much more interpretability, right? If that issue is not there, and you are and you are doing certain sales forecasting or to understanding what kind of videos people will watch and all those things, so your major aim will be to create a model. Might be complex, but you look into what is your accuracy rate of your prediction, right? So this part I'll just quickly go through because multiple times you must have gone through the regression. So basically, like our aim is to reduce the prediction error, right? And that is where the uh, ordinary least square method is utilized, right? So the question is why I cannot use the, see, there are two options, right? I can take the absolute value of the residuals, right? So it is not that negative is there and positive, the error will become 0. Or I can take the least square value, right? So either way I can create a model, right? So why I'm taking this least square value is not that most commonly used. That was the criteria, or that was the region when it was started. Uh, Generally, what happens if I'm taking, let's say, same example, if I take what I was showing you, absolute value, something which is, let's say, error is your prediction is 4 and actual value is let's say 10, right? In that case, if I take absolute value, so 4 minus 10 is 6. The error or the residual what will come is 4 minus 10 minus 6. Absolute value of that is 6. But if I'm taking a square of that, so that value will become 6. Square of that is 36, right? So in that case, why I use least square is I'll penalize the more error. Whenever there is a more error, I'm going to penalize it more because I'm taking the square of that. So the model is built in such a way that it is going to penalize as and when your deviation from the actual value increases. So if there is a penalty in deviation, so the model will be able to create whatever line or whatever equation such that the deviation from the mean, deviation from the actual value is very small, right? So then one question most times being asked that why we take the ordinary least square, or why don't we take a absolute value of residuals to minimize the model or to create a model? Why basically ordinary least square is utilized, right? So the answer is the model we are creating is to penalize any simple deviation, or any deviation comes, we are taking a square of that, right? So that it will penalize the model in case there is many more deviations, right? So that model will be a very parsimonious model. It will be a model which will be able to kind of minimize those kind of errors, right? Is this part clear why you are taking square, not absolute values?
Yes, sir.
Okay, assessing the correlation, right? Because before you create a model, ideally you should have a scatter plot showing relationship between your dependent variable and independent variable, right? Out of these 4, let's say in y, whatever your poverty is there, poverty. So I have a data set what I've used in poverty in USA and percentage of high school graduates in that household, right? And these are the 4 plots. So in y-axis your percentage of poverty, in x-axis percentage of household kind of having like kind of household sorry, high school graduates, right? So that means which of the kind of model, or which of the out of this chart or scatter plot, which has the strongest correlation?
So B.
B. Any other answer? Why not D?
So D is more scattered as compared to B.
Okay, why
The
not A?
points are.
C is obviously very scattered. I agree.
Yes.
So
Why not
A
A?
has multicollinearity.
Yes, sir. It is not linear.
No, multicollinearity is about the dependent variable, right? If I take both dependent variable and I'm trying to find the correlation, that is where the multicollinearity happens, right? Here it is between the curve is between, or the scatter plot is between the dependent and independent variable.
So A is not a linear representation. It is showing a curve.
Correct. So whenever somebody asks you about the correlation, right, always remember correlation means linear association, right? Though here it seems very less scattered, right? But when we are talking about the strongest correlation, right, it is B, right? Scatter plot wise, this seems this is following that non-linear curve, right? This is a linear line I can put, right? Whenever you talk about correlation, correlation means linear association, whether these two variables move in the same direction in a linear mode, either increase or decrease, right? So somehow, Anusa, I think you were asking about multicollinearity. Multicollinearity you will check when I have multiple dependent variables and I'm trying to see that, okay, whether these dependent variables are related or correlating with each other or not. In this particular case, before creating a model, I'm trying to see is that whether there is a relationship between my independent variable and dependent variable, right? Not between two dependent variables.
Yes, sir.
So anyhow, residuals, we know residual is the difference between your actual data and the predicted data. So linear model with only linear effect. So this is the model which most of the times we use. There will be certain models that I was discussing, right? If I'm making a transformation of the variable, right? Linear model with non-linear effect, right? The other part, other scatter plot, what we just, if I change the dimension, or I can transform the variable from x to x square or square root of x or log x, right? I can still fit a linear model, right? But again, linear model with non-linear effect. So these kind of variables have been transformed, right? X1 square or x2 square. So they have been transformed.
What is the meaning of non-linear effects?
Okay, so this is basically a polynomial model, polynomial regression you are creating. So what it means is your plane or whatever line or plane which you are creating, that model will be no longer valid, right? I'm still creating a linear model because that is what we discussed in one of the classes, right? The your linear regression definition doesn't mean that your dependent variables. So when I create that equation of y is equal to a plus bx, right? Let's say I write that equation. Let's say y is equal to a plus bx square, right? What I'm actually doing is I'm transforming that x, that effect I'm transforming. That is a I know that effect of x on y is no longer linear. That is a non-linear effect. X square has a linear effect with y. So I'm transforming x to x square, right? Because x has a non-linear effect on y, right? X is the relationship between y and x is not a linear, right? That I showed you in that Excel file, right? Just let me just open that. So same thing what we discussed here, right? Y is equal to yx. I have taken x as age, different age of different student. Y is the amount of money stipend they are getting, right? So I can create a model as simple y is equal to this x 3000, or I can take x square as variable, and my model will be like this 7.01412. Here x is actually x square, right? 7.012 x square plus 3000, and my model will outperform my previous model by 8%, because this is only 11.84 percentage explainability. This model has 19.69 percentage explainability, though it is not a, again, ideally I should take other variables also, right? So in this case what happens, x, whatever x is here, ideally it doesn't have a proper linear relationship with your y. It has a non-linear relationship with y. So I'm still creating a linear model. So when I'm creating this model, I'm creating a linear model with non-linear effects. That is where it is known as a linear model with non-linear effects.
Okay, sir. And so when do we use root x?
Okay, so that is where your first point is scatter plot, right? So if your curve, so just so this is where your x square will work, right? So you have to understand before creating a linear, before creating, because most of the times we just ask the softwares to create a model. We do not do any kind of testing. Ideally, your dependent variable, independent variable, you have to create a scatter plot. Then from the scatter plot, you have to understand which kind of relationship is there, whether it is y is equal to x square or y is equal to x cube, y has a relationship with x cube or root x. If this curve is not moving upward or coming little downward, right, then root x, or the difference between the points are smaller or the deviation are smaller, log x transformation can be utilized, right? So, so to answer your question, when to use root x or log x or x square or x cube, what kind of transformation you are going to use, that has to come from the scatter plot. So when you are creating a model, before creating a model, create scatter plots of y with the dependent variable with all independent variables separately. For each independent variables, create a scatter plot with your dependent variable, and from there you come to realize, let's say in this b case, I know that this is a linear relationship, I need not have to carry out any transformations. But if this was the scenario, a was the scenario, I might have to do a x square transformation, right? Because I know that whenever x is increasing and suddenly after certain point, for any movement in x, y is increasing rapidly, right? So that means y is not now moving with x, after certain value y is moving with x square, right? So that is where or x cube, right? So ideally if you are asking whether x square or x cube, you might have to do little bit of trial and error, first put x square transformation or x cube transformation. But if it is root x, so rather than it is increasing curve, it is decreasing, that means it is coming downward. In that case, you can make a transformation of root x.
Okay, sir. Sir, I have one more doubt.
Yeah,
Sir, if we carry on the regression, if we take normally carry out on x axis and y axis, if we take it on three axes, x, y, and z, so will that also be non-linear effects? And can we carry on three axes, the regression?
no, all your multiple linear regressions are so how many axes? Once you have
So
when you have multiple variables, let's say I have only one dependent variables and 10 independent variables or 5 independent variables, that won't be no longer xy axis. We are not able to visualize that because it will be a 10-dimensional field. More
so
than
will
three.
that also be non-linear effects, or
No,
that
no.
will be linear effects?
Oh, that is still if the relationship between y and x is
Yes,
in
sir.
linear association, that will be still a linear effect. But we are not able to visualize that because after 3 dimension we are not able to visualize. That will be no longer a line. That will be a plane or a kind of a optimal versions of a plane.
Okay, sir.
So it has nothing to do with the axis, because see, after 3, if I have 3 independent variables, I cannot actually visualize that because I know that x, y, g. After that, 4 dimension, 5 dimension, 6 dimension, I cannot visualize, right? Mathematically, I put those equations.
Yes, sir, because in that case, it will not be possible to draw a line as well because there are
Correct.
multiple
Correct.
dimensions. So we
So
will
if-
have to construct a
Yeah,
plane.
here if you see this is a plane, after 2, if more than 2, it will become a plane. More than 3, different shape it will take. I will not able to visualize. More than 5, 6, I will not able to visualize. But I can put a equation.
And sir, when we are having like more than two variables, like if we have 10 independent variables, and if we have to take non-linear effects, and if we are taking, for example, x square, we are taking beta naught plus beta 1 x1 square. So will that square be for all variables or just for one variable? Like all the 10 variables are we going to put square, x square?
No. Because see, scatter plot when you are creating, it is with, so for that question what you have, let's say I have 10 independent variables, right? So I'll create
Yes, sir.
10 scatter plot. For each y-axis, there will be independent variable. X-axis different. Sorry, y-axis your dependent variable. X-axis different independent variable. So
Yes,
for
sir.
each independent variable, I have to realize whether it transformation is required or not. Accordingly, I'll create my model. So
So
that,
if transformation is required, then we'll just transform only one variable, not all the variables.
no, if let's say out of 10 variables, 6 variables need transformations, you have to transform those 6 variables.
Okay, so we have to adjust this accordingly. Like if one requires a log x transformation and
Yes.
another requires x cube, so we will have
Yes,
to transform
yes,
all of them.
yes, yes.
Okay, sir. Okay, sir.
So that is where your stepwise regression helps. It is not that you are taking all those variables together. You will take one variable, transform it, see that what your model is doing, then take next variable. Because we do not do manually, automatically software. So you just have to tell that what kind of transformation is required, and software will do those transformation and put those variables in the model one by one, or either backward or forward elimination or backward elimination.
And sir, when we are transforming those variables, does it need to be in a particular form? Like if I'm transforming from log x to x, I'm making it from x cube to x. So is it necessary that it should come transformed as a variable x?
You will transform
Or
from
can-
x to log x, right? You will not transform from log x to x.
Yes, sir. So if I'm taking, for example, I've taken log x to log x cube to 3 log x, वैसे करके I've taken. So is it necessary that I'll have to take it into log format, or I have to take it into x cube format? Or it can be, one can be log x also, one can be x cube also, one can be x square
Yes,
also.
yes. Different variables will may need different transformation, right? Not necessarily all of them will have same transformation.
Okay, sir.
Out of 10 variables, let's say 6 variables are linear association. You need not have to have any transformation. 4 variables might need certain transformation, and all those transformations might be different transformations. So you have income data, it might need a square x or inverse of x. You have a age data, it might need a square x square or x cube. So different variables might need different transformations.
Okay, sir.
So in that knowledge of transformation will come because before model, if you create a scatter plot for each independent variable, with dependent variable, you create a scatter plot that will give you a clarity on what kind of transformation is required.
Okay, sir.
So these two are linear. If you have a nonlinear relationship, right? If the relationship displayed in your scatter plot is not linear, you will have to either run up a nonlinear regression analysis, like I said, polynomial regression, or transform your data. So if this kind of relationship is there, I might do a transformation of x square or x cube and try to see that by putting x square in place of x or x cube in place of x, whether my model is giving me better result, right? So that is the assumption linearity relationship between variables. When I say variables, it is dependent and independent variables, right? Because if there is a relationship between both dependent variable, then the problem of multi-collinearity will rise, which is a big, very bad thing for your model. And you have to like kind of, there are different methods to understand and eliminate those kind of multi-collinearity. We'll discuss that in the next class. Second assumption for the linear regression is the residual should be nearly normal, right? Can anybody tell me why it is required? When I'm plotting residual, why it should be normal? Residual, I hope all of you understand, right? If I'm creating a model, that is my predicted values. From the model, I'll get the predicted values. Actual data is given, right? Actual data is available, right? So the difference between actual data minus the predicted data which the model is predicting, right? The difference between them is residual. Because that part I'm not able to predict, right? That is the residual part which I'm not able to predict. So the point is why those residuals ideally, though it is never will happen that it will be actually kind of perfect, normal. But why do you think that
So the residuals need to be normal because that will prove that the model and the whatever assumptions that we're taking or the model fit is perfect, like it fits in, the model fits in. If the residual is not normal, then there is some problem with the assumption or with the model. That it means basically.
Okay, any other answers? So the if you see, we are writing nearly normal, right? Because getting a perfect normal again won't happen anytime. Very rare case. So why we are taking residual as normal, right? So the model errors, because see, the residuals are nothing but the error values which you are not able to predict. That is certain random. So what we are telling, these values, these residuals which are random, if I plot that, so see any random data you take, if I collect your age, and that is where your central limit theorem comes, right? If I take randomly age of MBA student or income of post MBA student, any frequency data, right? Any continuous data if I take, maximum probability that it will take a normal, right? It can be skewed. Normal, not necessarily it is a perfectly normal. It can be a skewed normal also, but it will be plotted normal. There will be certain outliers. There will be certain. Basically, normal means what? Maximum data points are mean, right? Maximum data points will converge to mean. So why we are talking about residuals as nearly normal when I'm plotting residuals? Why should have a near normal data? Because our assumption of model is that whatever model can explain, that has been taken care. Any error which is happening, that is of random nature. So whenever we plot any random data, it has to take a shape of a normal, if not a perfect normal, near normal data, right? So that's why the assumption is, if residual is not normal, that means there are certain variables which I have not taken, which is impacting my residuals, right? So that is where the assumption comes, that okay, second assumption of linear regression, that your residual curve when you are plotting, that has to be near normal. The fundamental or the principles of why we are telling that near normal, that because the errors or the residuals which are left out, right? That is basically, just a moment, I have a call. Sorry for that. So that is why the plan is, or the aim is, that if you plot your residuals, it will be near normal, right? Because we believe that those errors are which are happening, that is of random in nature. Whenever you plot a random continuous data, it takes a shape of near normal, right? If it is not near normal, that means there are certain problem with your model. That means either you have not taken all the correct independent variables, or data transformations are not proper. So all those kind of errors might be there, right? Then assumptions for linear regression 3. Here we talk about homoscedasticity or heteroscedasticity, right? So by looking and by reading it, can anybody explain what is that? Anyone? These are the, again, there are actually 6 assumptions, but these 3 are the major assumptions. In the next class, when we talk about the multicollinearity, is the 4th assumption which Anvesa was talking about. That we'll discuss in the next class. But what do you mean by this? These are the, again, like anytime anybody asks in the interview what are the assumptions, at least these 3 you should be able to talk, right? Linear association between dependent and independent variables. Residuals plotting has to be near normal. Then third is the homoscedasticity.
So homoscedasticity might be like, I'm guessing that the points or the scatteredness will be very similar. Homo means they are same or they are of same size throughout the line. So the scatterness will be constant or near to constant throughout the line.
Okay, but why do we need that, right? What will happen if there is a trend, if there is increasing? In this case it is increasing, it is decreasing, right? As the line progresses, right, it is decreasing. In the first case it is increasing, your scatterness is increasing. In the other case it is actually decreasing. If the other cases we are taking, what will be the problem? So in the past two cases, if there is a trend, what is a problem with that?
So there might be a skewness to the graph.
Okay, it is not about the skewness, it is about there is a trend in your residuals. That means as and when your dependent variable increases, decreases, your residuals are increasing and decreasing. So what does it mean? That then there is a relationship, because when I'm saying residuals are random, that means there is no relationship. Residuals are randomly coming up. I do not have control on them. But if there is a trend, means that is some relationship between your dependent variables, because if dependent variable increases, either it is increasing or decreasing. So in this particular case, when the line progresses, the residual values are also increasing. In this case, when the line progresses, residual values are coming to zero, right? Decreasing, right? So in that case, what happens? There is certain relationship between your residuals and your whatever dependent variables you are taking, or whatever model you are creating, which should not happen. Because remember, residuals means the random error which model cannot control. But if I'm saying that there is a trend either increasing or decreasing, that means there is certain association between your residuals, the errors, along with your data points. That means I have not created a proper model. Homoscedasticity means your error remains constant. There is no change. As and when your dependent variable increases or decreases, it has no impact on your error values. Error values still remain random, right? So in that case, what it means? My model is able to, whatever accuracy is there, I can depend on that. But if there is a trend, that means residual errors, those random errors, no longer are random. There is certain connection between those errors or residuals along with your uh, data points or the dependent variable, sorry, independent variables, right? So these
Sir,
three are,
also in
yeah,
sorry,
go
sir.
on. Yeah, go on, go on.
So also in heteroscedasticity, so we can see that there is a convergence and a divergence patterns of the plots also. These are not matlab, like in normal, like best fitting line if we are drawing. So matlab, in this case it will be very difficult to draw it, because at one point it is more convergent and at the other end it is more divergent. So the line might also, the best fitting line might also be wrong, that might be formed out of it.
Okay, so these points are not your dependent variables. Okay. These points are actually your residuals.
Plot points.
Residuals. So
Okay, sir.
after, so these are the residual plots. So this is not the graph or the scatter plot what we are seeing. So these are the your after you create a model, right? I'll show you in the next class when actually you do a residual plot. So you'll come to know that these are not the scatter plot. This is the residual plot, right? So residual plot means your predicted value, your actual value minus predicted value. Those points, those numbers, what we are coming, right? And this is the central line. This is the zero line. These are the negative. These residual values are negative. These residual values are positive. So when you see these points are forming a trend, forming a shape, that means they are related to your model. They have certain impact on your model, because as and when your value of your independent variables are increasing, these residuals are changing to certain extent, right? So here the residual numbers or the values were, let's say, +1, -1. Here if you go, they're increasing up to +5, -5, right? So that means your residual values are changing with respect to your independent variables. That means there is some relationship between your error terms and your independent variables, which should not be there. Because what I'm telling, residuals are random error, which I cannot control. But if there is a relationship, that means there is a problem with my model. So to answer your question, this is not the scatter plot of dependent or independent variable. This is the residual values. I'll show you that in the next class, so that it will be more clear.
Okay, sir.
So then what about the hypothesis? So that is where the explainability or interpretability of the model comes into picture. So this what we had discussed in earlier also BRM classes also. So our null hypothesis will be that the regression model does not fit the data better than the baseline model. Baseline model is our, if let's say that day we discussed, right? Baseline model is the mean value. If I do not have any assumption, if I say that okay, these are the age group from 21 to 25, and these are the stipend amount. Now you predict for a person who is 24-year-old, right? You are not creating a model. I will not ask you to create a model. So what will you do? You take an average and say that okay, or maybe he will whatever earn this much amount, right? So that is your baseline model. So when we are creating a null hypothesis means no change, right? Everything is same. There is no change from the baseline model. So the prediction is, or the assumption is that all the coefficients beta 1, beta 2, whatever number of variables beta k, these are the standardized regression coefficient. Those are 0. What it means is the model which I'm creating is similar to my baseline model. There is no change. My alternate hypothesis will be the regression model does fit the data better than the baseline model. That is the mean value. Not all the betas are 0, right? Remember that. Even if I have able to create a model out of 10 independent variables, right? Let's say 4 or 6 independent variables or 8 independent variables did not work. They are not able to predict. But I have 2 independent variables which are helping me to create a better model, right? Then for them, the betas won't be 0. Betas will have certain values. So that will prove my alternate hypothesis as true. That means I'm able to create a model which is better than the baseline model. Baseline model is nothing but your mean value. If I do not have any information, if somebody asks me to predict something, I'll just take mean value. So let's say I do not have your any other data. I do not have your previous educational experience, your previous, let's say, how much effort you are putting for exam, how much effort you are putting in the class. I have only your internal evaluation and your whatever grade point you have scored. Suddenly, if I somebody asks, okay, how much she will score or how much he will score, what will take? I'll take the class average because I do not have any more data. Just imagine the scenario, right? I have all the CGPA point or the whatever in this course, whatever internal evaluation so far we have done. We have done only one, right? I have that much mark, and suddenly somebody asks that, okay, what will the score of a certain individual, right? Without any other information, I do not know anything about you, right? Without information, without any additional information, what will I do? Simplest thing is that I'll take the average, class average, and say that okay, he or she might score this much, right? Like in the quiz it happens, right? I get the median score or the mean score. If I do not have any information, I'll say that okay, a person will score this much, right? So that is the baseline model without any information. My alternate hypothesis is that if I get certain additional information, how much time you are or how many additional certifications you have done on analytics or how much effort you put on analytics, then I might able to predict better. Say that okay, because these persons have done certain certifications, they have attended other analytics classes, they might score little better, right? So that will be my alternate hypothesis or alternate model, right? We always try to prove the alternate hypothesis by disregarding or by disproving the null hypothesis, by rejecting the null hypothesis. So I'll say that yes, I have built a model if I have the information about the student, how much effort they put in the class, how many certifications they have done in analytics, what are their grade point in other analytics subjects. I'll be able to predict how much they'll score in this subject, right? So obviously R square value, the R square is nothing but the amount of explained variation in terms of total variation, right? Because see, whenever you are creating a model, like I said, certain information, certain values will be random. We will not able to predict with 100% accuracy, right? So what R square says is how much the explained variation in comparison to total variation, right? R square is nothing but the square of correlation coefficient. It tells us what percentage of variability in the response variable is explained by the model. Response is your outcome variable or the dependent variable, right? The remainder of the variability is explained by the variables not included in the model or by inherent randomness in the data, right? So it can be up to different regions. Either it might be the scenario like in the case I showed you, student data, the R square is only 11%. There can be multiple variables I have not taken, right? Or it can be randomness. Some information will be such random that it will never, you will not able to predict that, right? Then hypothesis test. This remind me, I'll show you, because rather than just going through the this text, I'll show that during an example, and kind of that will be better. So what we basically try to see that whatever model we are creating, whether, because you always remember, it is never possible to take all the data, right? And if you remember what we discussed in BRM, population and sample, we are taking a sample data, whether it is Amazon, Flipkart, they are working on some amount of data, and they want to predict for the population, right? Having the same characteristics, right? So when I want to predict the purchase behavior of individuals from 18 to 45, I have to take sample from those age group only. If I've taken all the sample from 18 to 30 and I want to predict some for people beyond 30, errors will be increasing, right? But obviously I cannot take information of 10 crore of people who are between 18 to 45 data, or 18 to 45 age in India. So I have collected a few lakhs of data sets, few lakhs of individuals information, right? Those people who have willingly shared those information. Based on that, I'm predicting for all the individuals, all the 10 crore or 1 crore people who use my service, right? So that is, again, we carry out a t-test to understand that, okay, whether that value, I'll show you that when we go and create a regression model, whether my model, I'm able to reject the null hypothesis, saying that whether the coefficient what I'm getting is statistically significant. Because the aim is to create a model where obviously my prediction is better and I'm able to explain the variables, right? I'm able to say that, okay, if somebody's BMI increases, my profit decreases. And second thing, I should able to tell that by how much percentage if BMI increases, or by how many points BMI increases. If BMI increases by 1 point, what will be the impact on the profit? How much profit decrease in profit will happen, right? And this is where the confidence interval is important, right? If you go beyond a certain level, you need to have a range of data, right? I cannot say that, okay, the salary of the student will be this much. I need to have a confidence interval that, okay, salary of the student might be within this range, or the profit for the insurance individual for which you have already completed the exercise will be in this range. I'll show you how to calculate that. So this is a, how much time we have left? Okay. Okay, we'll discuss this quickly in the next class. Maybe 10-15 minutes of work is left. I just kind of want to show an example. Anyway, like, we'll start from here, because this also I have not showed you in the SAS Studio. Just quickly, I wanted to show you one thing. So let me show you that and we'll be done for the day. So whichever data set you have, whether that insurance data set or any other data set, right? So go to task and utilities. Linear model, right? So if you see, there are different type of regressions, right? So linear regression you must have already done for your exercise. Now what you do, go to predictive regression model, right? Now if you see, there is a opportunity, there is a chance for that same data set if you can use and create your validation and test data set, right? If I just click here, it will ask me what is the, like, out of total data set, what is the proportion of validation data set and what is the proportion of test data set. Whatever you can take, let's say I take 0.15 patch, validation data set and 0.155. That means 15% of the data will be put on validation data, 15% of data can be put on the testing data, right? So like that, you take a data set, then put your dependent variable what you have put in the earlier case, right, for your exercise, and try to see that what additional information you are getting, right? And we'll discuss this in the next class. So there are different model, there are different selection, how to select a model. There are different criteria what we have not discussed, only we have discussed on the R square part. There are additional, obviously adjusted R square also you are aware of, but some additional information is also there which we'll discuss, right? But just for tomorrow's, or sorry, not tomorrow's, for the next class, come with your answers after running this model, right? Obviously you have to select dependent variable, you can select profit or whatever, claim amount, independent variables, classification or categorical variables, and continuous variables, like you did the exercise. I don't think you have used this one, right? Predictive regression model. Anyone use this one? I think you would have used this linear regression, right?
Yes, sir.
Okay. So now do the same thing. You need not have to submit anything. Just try it on your own using this data. So the main point is what we discussed in the earlier class, right? Validation dataset and training dataset. See that how it is creating. And I need to get an answer that what is this? Specify the random seed, right? Why this is asking me, right? If I just put that and put that 1, 2, 3, 4, 5, how it is going to help me?
Sir, can I say the answer about this?
Yeah, yeah.
Sir, because in the predictive modeling, when we are dividing it into training model and the testing model. So, sir, the training model is going to take 80% of the data, and the testing is going to take 20% of the data. However, when we are
In this
taking
case, it
the
is actually 70%, right? Because I have
okay, yes, sir.
0.15, 0.15. So that means yes, 70% training data set, validation 15, and testing is 15%.
Yes, sir.
Yes.
So, sir, when they'll split the data, they are going to randomly select the, they will randomly split it into 70-30. So if I do not take a set seed, it might be possible that for you, what you're getting the training and testing data might be very different from me. So hence for the output or the result will also vary per person. So that is why we use this random set seed, so that my training and testing model is not different from yours. So
Exactly.
that is the reason we use it.
Yes. So random seed actually helps because see, whenever we are working in a company, right, different individuals might work in the same model, right? Because if I have used a different random seed, the proportion, the way it is dividing the training and testing or validation data set will be completely different, right? Though we are using the same model, though we are using the same technique, right? So that is where in some cases you have to define the random seed, so that if I say that okay, I have used this random seed, the other person, let's say Apurva or somebody, someone of you are using the same model, trying to build a same model. If you put that, the rest, the data which is being selected in training, the data which is getting selected in validation, the data point which are getting selected in your testing data set will remain same. So that we'll get the we'll get the similar results, right? So that is why it is important to specify the random set. Again, any kind of, whether it is Python, R, or SAS, wherever you use it, this random seed gets used. Okay, so we'll stop for the day. Take care, and please run this predictive regression model
Sir.
before coming to next class.
Sir,
Yeah.
sir, I missed my attendance in the beginning.
Roll number.
So 062.
Okay.
Alicia, sir. Alicia.
Anyone else?
Roll 53.
What is the roll number?
So 53, 53.
Okay.
Sir,
Sir,
I have a... Okay.
Yeah,
please,
one by
sir.
one. Roll number?
57.
57, okay. Anyone else? Yes, Apurva,
Sir,
you had
I
a
have-
question?
Yes, sir. So the data set that you had given for the assignment, sir, in that I had one doubt.
Yeah.
Sir, over there, I have taken the dependent variable as customer revenue and the gender, age, household income, years as customer, and customer subscription count as the input factors. So, sir, over there, sir, when I saw the data, sir, I was seeing that the customer subscription count and the customer revenue, they are very, I think but both of them are not exactly, we cannot say that dependent variables, but yes, like for example, over there the subscription count is given 3 and the customer revenue over here is $45, and in one it is given that the customer subscription count is 1 and the customer revenue is $15. So $45, if I divide it by 3, it is also coming as 15. So I
Correct.
was saying that customer subscription count is kind of, I can say that with the customer revenue, it is creating a very sensitivity, sir. So, and sir, when I carried out the regression, so if I did not take the customers count, subscription count, so the R square and the adjusted R was coming around 20%. But when I took that data, my R square, it increased it to 60%, sir. So, sir, I was thinking that the subscription count was very, it is
Exactly. So
causing a lot
that is something which has to come in your analysis. And what you said is exactly correct, right? Because if I have the subscription, the more the subscription, let's say somebody has taken multiple subscription, the revenue the customer is earning from that, sorry, the company is earning from that customer is more, which is a common sense, right? You need not have to
Yes,
build
sir.
a model for that. Now the question is, because see the number more subscription is there, and the obviously the revenue the company will earn is more. Without taking that, whether my model is performing better, right? If I'm creating a model in using that and my R square is coming 80 or 60 or 70, and by removing that my model is going 20 or 30%, that means I have to create a better model. I have to take some additional variables. So exactly that has to come in your analysis, saying that these are the two variables and customer subscription data. So when you say sensitivity, basically correlated, right? Customer subscription
Yes,
data is highly correlated with your customer revenue, which is not a bad thing. But I know that is a common sense, right? If I know that okay, your age and weight, age increases to certain maybe 20 or 30, as your age increases, your weight increases. That is almost a common sense. Apart from that, but my interest area will be what other things increases the weight of a person. Maybe unhealthy lifestyle, unhealthy food habits, right? Because that age I won't have any control, but other things I will have control, and I will have plan or I'll have certain things to reduce that, right? So your question is valid, and that has to come in your analysis, saying that okay, this is customer subscription data. If I remove this variable, my explainability is model is reducing by 40%, 50%. That means my model is not performing better. So ideally, I should get other variables which will be able to help me to build a better model.
so we'll take that variable or will we not? Because not
We'll take.
every
We
customer
cannot say
has
that.
taken
Yes,
$15.
will take that. We'll take that. But in our analysis, we'll say that this is one of the major variable, right? Because see, at the end, decision has to be there, right? Prediction is
Yes,
not
sir.
only for okay creating a model. Now the point is, I know that customer subscription is improving my revenue, but what benefit it is going to give to the management? They already know that. If
Yes,
subscription
sir.
increases, that doesn't mean that I'm removing that from my model. But apart from that, which are the other variables which have major impact, right? Because see,
So,
first,
sir,
yeah,
yes, sir.
well, you will take that in your model, but you'll show the difference also. You'll show that if I take out this variable, my other uh, variables, let's say if I do not take the customer subscription count, other variables are only able to explain this much of the kind of model, right? This much of the customer revenue. Now the management has to decide whether they'll consider those variables or not.
So can the customer subscription count not also be dependent variable in some case, sir? Because
Yes,
count is, because we will
yes.
also focus
Number
on
of
increasing the count.
subscriptions. Yes, you can take that also as a your dependent variable if you want to increase the subscription count. You will say that okay, I will build a model. Say that what are the variables which are improving my customer subscription count. Same model I can create in different way rather than taking revenue.
So, sir, then my problem state will change if I take
Yes,
one as, and if I
yes.
am, so both of them are dependent. So if I'm taking my customer
You have to take
subscription
only
count
one.
as the,
So revenue cannot be, see, your revenue is dependent on customer subscription count, but customer subscription count cannot be dependent on your
no,
revenue, right?
yes, sir.
So
Yes,
when you
sir.
are taking customer subscription count as your dependent variable, remove that revenue out
I
of
will
your
have to
model.
remove the revenue. Yes, sir. But that will not be a very good utilization of the data, I think.
No, if
Because
you are
I'm
building a model where you are saying that customer subscription count and with other variables, you are able to create a better model. You'll go to the management and say that we are approaching this problem in a wrong way. Ideally, we should focus on our customer subscription count. Because if I'm able to predict that in a better way, that will improve our revenue because there is a high correlation between customer subscription count and revenue. Our focus area will not be only on the revenue. Our focus area now will change to the increasing the customer subscription count.
okay, sir. So can I get some time because I'll have to add
Yeah,
that
yeah.
also.
Do
I've
it by
not
next
added
class. Do it by next class. We'll see.
Okay, sir. Thank you, sir.
Yeah, yeah. Chalo, take care. Bye bye.